Hello everyone, myself Tejashree. I am studying Electronics Communication Engineering second year in SRIT College, Anantapur. My roll number is 23401A04B6. The topic is Signal Bandwidth in Communication System from the subject Signal Systems and Stochastic Process. The subject code is 23A04301. Definition of signal bandwidth in communication systems. Firstly, the introduction to the signal bandwidth. Signal bandwidth is a critical concept in communication systems. It defines the range of frequencies that a signal occupies. Understanding bandwidth is essential for efficient data transmission. Here you can see the graph illustration of bandwidth of musical signal. F1 is equals to 20 Hz, F2 is equals to 15 kHz. Between F1 and F2 the bandwidth is present. Definition of bandwidth. Bandwidth is the difference between the highest and lowest frequencies of a signal. It is typically measured in hertz. A wider bandwidth allows for different data rates and better signal quality. Types of bandwidth. There are several types of bandwidth including analog and digital bandwidth. Analog bandwidth refers to the frequency range of analog signals. Digital bandwidth pertains to the data rate of digital signals, often expressed in bits per second. Importance of bandwidth in communication. Bandwidth determines the capacity of a communication channel. Insufficient bandwidth can lead to data congestion and loss. Adequate bandwidth is essential for applications like video streaming and online gaming. Channel capacity. A very important consideration in data communications is how fast we can send data in bits per second over a channel. Bandwidth and data rate. Data rate is the amount of data transmitted in a given time influenced by bandwidth. Higher bandwidth generally enables higher data rates. This relationship is crucial for network design and optimization. Bandwidth versus data rate. Here is the comparison between bandwidth and data rate. In bandwidth is defined as the amount of data that can be sent from one point to another across a given path. Data rate transfers to the speed at which data is transferred from one device to another or between a peripheral device and a computer. Bandwidth is measured in bits per second, megabits per second or gigabits per second. Data rate is raw radio transmission speed, which is generally measured in megabits per second. It refers to the number of bits per second that a link can send or receive at one time. It describes the transmission speed, which means the actual amount of data transferred. Given the data rate, bandwidth can be determined by multiplying data rate with 8. Given a bandwidth, divide by 8 to obtain the data transfer rate. Bandwidth in analog signals. For analog signals, bandwidth can be defined as the frequency range over which the signal is significant. It is often characterized by the cutoff frequencies in filters. The concept of bandwidth is vital for understanding modulation techniques. Here is the graph between frequency and normalized output current. Bandwidth in digital signals. In digital communication, bandwidth relates to the symbol rate of the transmission. Digital signals often require more bandwidth than analog signals for the same quality. Techniques such as compression can affect the effective bandwidth used. Here the Nyquist theorem. Nyquist theorem states that the maximum data rate is twice the bandwidth of the channel. This principle is fundamental in determining the limits of data transmission. It emphasizes the importance of bandwidth in achieving high-speed communication. Nyquist theorem is equal to the sampling rate should be at least twice the frequency of the highest frequency in the sound wave. Humans have an audio frequency range of 20 to 20,000 Hz. Therefore, audio should be sampled at least a rate of 40,000 Hz. Ideally, the sampling rate should be much higher than this. Maximum frequency is equals to 1 by 0.5 is equals to 2 Hz. Bandwidth allocation. Bandwidth allocation refers to distributing bandwidth among multiple users or applications. Efficient allocation is crucial for maximizing network performance. It often involves quality of service considerations to prioritize traffic. Bandwidth limitation factors. Several factors can limit effective bandwidth, including interference and noise. Physical properties of transmission media also play a significant role. Understanding these limitations helps in designing robust, robust communication systems. Bandwidth limitation. Frequency bandwidth is measured at the point where gain falls to 0.707 of maximum signal. Open loop configurations are extremely bandwidth limited. Closed loop configuration significantly increases an op-amp's bandwidth. Here is the graph between gain and frequency. At the top, open loop gain, and the bottom, unity gain frequency, and the second one, closed loop gains, and third one, minus 3 dB points. Measuring bandwidth. Bandwidth can be measured using various techniques such as frequency response analysis. Tools like spectrum analyzers are commonly used for this purpose. Accurate measurement is critical for system performance evaluation. Here you can see the figure segment. Bandwidth in wireless communication. Wireless communication systems face unique bandwidth challenges due to environmental factors. Bandwidth efficiency is essential for maximizing the capacity of wireless networks. Techniques like frequency hopping or spread spectrum are often employed. Future of bandwidth. The demand for bandwidth is continually increasing with emerging technologies. Innovations in optical and wireless technologies aim to meet this demand. Future developments may significantly alter how bandwidth is perceived and utilized. Case studies. Various case studies illustrate the impact of bandwidth on real world applications. Examples include the evolution of mobile networks from 2G to 5G. These studies highlight the importance of bandwidth planning in communication strategies. Here you can see the figure collaboration between and within buildings. Finally, the conclusion is understanding signal bandwidth is essential for effective communication systems. It influences data transmission rates, quality, and overall performance. Continuous advancements in technology will shape the future of bandwidth utilization. Bandwidth of signal. Different definition of bandwidth: half power bandwidth and noise equivalent bandwidth, or null to null bandwidth, or fractional power contaminate bandwidth, bounded power spectral density, or absolute bandwidth. Here you also see the figure. Thank you for watching this video.